Hi, hello students, welcome back to Call Me Honest. Next, we are going to discuss class 9th Mathematics NCERT syllabus. Chapter number 2, Polynomials. We have studied algebraic expressions, their additions, subtractions, multiplications and divisions in earlier classes. We also have studied how to factorize some algebraic expressions. We may also recall the algebraic identities such as x plus y whole square equal to x square plus 2xy plus y square, x minus y whole square equal to x square minus 2xy plus y square, and x square minus y square equal to x plus y into x minus y, and their use in factorizations. In this chapter, we shall start our study with a particular type of algebraic expressions called the polynomials and the terminology related to it. We shall also study the remainder theorem and factor theorem and their use in the factorizations of the polynomials. In addition to the above, we shall also study some more algebraic identities and their use in factorizations for evaluating some given expressions. Polynomials in one variables. First topic, polynomial in one variables. Let us begin by recalling that a variable is denoted by a symbol that can take any real value. We use the letters x, y, z, etc. to denote the variables. Notice that 2x, 3x, minus x, minus 1 by 2x are all algebraic expressions. All these expressions are of the form constant into x. Now, suppose we want to write an expression which is a constant into a variable and we do not know what the constant is. In such cases, we write the constants as a, b, c, etc. So, the expressions will be ax. Say no? Okay. However, there is a difference between a letter denoting a constant and a letter denoting a variable. The values of the constants remains the same throughout a particular situation. That is, the values of the constants do not change in a given problem, but the value of a variable can keep changing. Now consider a square of say 3 units. What is its perimeter? We know that the perimeter of a square is the sum of the length of its 4 sides. Here each side is 3 units. So its perimeter is 4 times 3, that is 12 units. What will be the perimeter if each side of the square is 10 units? The perimeter is 4 times 10, that is 40 units, 40 square units. 40 units. In such cases, the length of each side is x units. The perimeter is given by 4 times x units. So, as the length of the side varies, the perimeter also varies. Can we find the area of the square PQRS? Yes, it is x times x, that is x square unit. X square is an algebraic expression. We are also familiar with other algebraic expressions like 2x, x square plus x square plus 2x, x cube minus x square plus 4x plus 7, etc. Note that all the algebraic expressions we have considered so far have only whole numbers as the exponents of the variables. Expressions of this form are called polynomials in one variables. In the examples above, the variable is x. For instance, x cube minus x square plus 4x plus 7 is a polynomial in x. Similarly, 3y square plus 5y is a polynomial in the variable y. And t square plus 4 is a polynomial in the variable t. In the polynomial, if the polynomial x square plus 2x, the expression x square and 2x are called the terms of the polynomials. Similarly, the polynomials 3y square plus 5y plus 7 has 3 terms. Which are the terms? 3y square, 5y and 7. Can we write the terms of the polynomials minus x cube plus 4x square plus 7x minus 2? Yes, the polynomials there are 4 terms. Which are the 4 terms? Minus x cube, 4x square, 7x minus 2. These are the 4 terms. Each term of a polynomial has a coefficient also. So, in minus x cube plus 4x square plus 7x minus 2, the coefficients of x square equal to minus 1. The coefficients of x cube equal to minus 1, the coefficient of x square equal to plus 4, coefficient of x equal to plus 7, and the coefficient x raised to 0, which is equal to 1, equal to 2, 1. 2 is the coefficient of x raised to 0. Do you know the coefficient of x in x square minus x plus 7? Yes, x square coefficient 1 and x coefficient which is equal to minus 1. Minus 1. 2 is also a polynomial. In fact, 2, minus 5, 7, etc. are examples of a constant polynomials. The constant polynomial 0 is called the zero polynomial. From here, first equation we have plus 2. X square plus 2x. No. Minus 5. 2, minus 5, 7 are examples of constant polynomials, which is called zero polynomials. Constant polynomial 0, x raised to 0 is called zero polynomials. This plays a very important role in the collections of all polynomials, as you will see in our earlier classes. Now consider in algebraic expressions such as x plus 1 by x, root x plus 3 and cube root of y plus y square. Do you know that you can write x plus 1 by x equal to x plus x dash? Here the exponent of the second term, that is x raised to minus 1, is minus 1, which is not a whole number. So this algebraic expressions which is not a polynomial. Again, root x plus 3 can be written as x raised to 1 by 2 plus 3. Here the exponent of x is 1 by 2, which is not a whole number. So is root x plus 3 is a polynomial? No, it is not a polynomial. What about cube root of y plus y square? It is also not a polynomial, because cube root of y means y raised to 1 by 3. The exponent is 1 by 3. Y is 1 by 3, which is not a whole number. So this is not a polynomial. If the variable in a polynomial is x, we may denote the polynomial by p of x or q of x or r of x, etc. So for example, we may write p of x equal to 2x square plus 5x minus 3, q of x equal to x cube minus 1, r of y equal to y cube plus y plus 1, s of u equal to 2 minus u square plus 6u raised to 5. A polynomial can have any finite numbers of terms. For instance, x raised to 150 plus x raised to 149 plus etc. plus x square plus x plus 1 is a polynomial with 151 terms. Consider the polynomial 2x to 5x cube minus 5 square and y and u cube, etc. Do you see that each of these polynomials has only one term? No? 2x. For that, polynomials having only one term are called monomials. Now observe each of the following polynomials: p of x equal to x plus 1, q of x equal to x square minus x, r of y equal to y raised to 0, y raised to 9 plus 1, t of u equal to u raised to 50 minus u square. How many terms are there in each of these? Each of these polynomials has only two terms. Polynomials having only two terms are called binomials. Bi means two. Similarly, polynomials having only three terms are called trinomials. Tri means three. Some examples of trinomials are p of x equal to x plus x square plus pi, q of x equal to root 2 plus x minus x square, r of u equal to u plus u square minus 2, t of y equal to y raised to 4 plus y plus 5. Now look at the polynomial p of x equal to 3x raised to 7 minus 4x raised to 6 plus 6x plus 9. What is the term which the highest power of x? 3. It is 3x raised to 7. The exponent of x in terms in this term is 7. Similarly, in the polynomial q of y equal to 5y raised to 6 minus 4y square minus 6, the term will be the highest power of y is 5y raised to 6 and the exponent of y in term is 6. We we call the highest power of the variable in polynomial as the degree of the polynomial. So the degree of the polynomial 3x raised to 7 minus 4x raised to 6 plus x plus 9 is 7 is the degree of the polynomial, and 5y raised to 6 minus 4y square minus 6 is 6. The degree of a non-zero constant polynomial is 0. The degree of a non-zero constant polynomial is 0. So we have to solve some examples. Find the degree of each of the polynomials given below. First one, x raised to 5 minus x raised to 4 plus 3. Solution. The highest power of the variable is 5. So the degree of the polynomial is 5. Second one, 2 minus y square minus y cube plus 2y raised to 8. 2y raised to 8. The highest power of the variable is 8. So the degree of the polynomial is 8. Last one, 3. The only term here is 2, and which can be written as 2x raised to 0. X raised to 0 means 1. So the exponent x equal to 0. Therefore the degree of the polynomial equal to 0. Now observe the polynomials p of x equal to 4x plus 5, q of y equal to 2y, r of t equal to t plus root 2 and s of u equal to 3 minus u. Do you see anything given among all of them? The degree of each of these polynomials is 1. A polynomial of degree 1 is called a linear polynomial. Some more linear polynomials in one variables are 2x minus 1, root 2y plus 1, 2 minus u. Now try and find a linear polynomial in x with 3 terms. We would not be able to find it because a linear polynomial in x can have at most 2 terms. So any linear polynomials in x will be of the form ax plus b, which a and b are constants and a not equal to 0. Similarly, ay plus b is a polynomial in y. Now consider the polynomials 2x square plus 5, 5x square plus 3x plus pi, x square and x square plus 2 by 5 into x. Do you agree that they all are of degree 2? A polynomial of degree 2 is called a quadratic polynomial. Some examples of a quadratic polynomials are 5 minus y square, 4y plus 5y square, 6 minus y minus y square. Can you write a quadratic polynomial in one variable with foremost 3 terms? If we list a few more quadratic polynomials, we will find that any quadratic polynomial in x is of the form ax square plus bx plus c, where a not equal to 0 and a, b, c are a constants. Similarly, quadratic polynomials in y will be of the form ay square plus by plus c, provided a not equal to 0 and a, b, c are a constants. We call a polynomial of degree 3 a cubic polynomial. Some examples of cubic polynomial x are 4x cube, 2x cube plus 1, 5x cube plus x square, 6x cube minus x, 6 minus x cube, 2x cube plus 4x square plus 6x plus 7. How many terms do you think a cubic polynomial in one variable can have? It can have most 4 terms. These may be written in the form ax cube plus bx square plus cx plus d, where a not equal to 0 and a, b, c, d are constants. Now that you have seen what a polynomial of degree 1, degree 2 or degree 3 look like, can we write down a polynomial in one variable of degree n for any natural number n? A polynomial in one variable x of degree n is an expression of the form a n x raised to n plus a n minus 1 x raised to n minus 1 plus etc. a1 x raised to 1 plus a0 x raised to 0, where a0, a1, a2 etc. an are constants and an not equal to 0. In particular, if a0 equal to a1 equal to a2 equal to a3 equal to a raised to an equal to 0, all the constants are 0, we get the 0 polynomial, which is denoted by 0. What is the degree of a 0 polynomial? The degree of 0 polynomial is not defined. So far we have dealt with polynomials in one variable only. We can also have polynomials with more than one variable. For example, x square plus y square plus x, y, z, where variables are x, y and z, is a polynomial in 3 variables. Similarly, p square plus q raised to 10 plus r, where the variables are p, q and r, u raised to 3 plus v square, where the variables are u and v are polynomials in 3 and 2 variables respectively. We will also study such polynomials in details later. Second question exercise you have to solve on next classes. Okay. Thank you, students.